Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about TLM ports in UVM. So basically TLM stands for transaction level modeling ports in UVM, and these are basically communication mechanisms used to transfer transactions like sequence items between different components, like we have sequencers, drivers, monitors and scoreboard. So for transferring the data or for transferring the transactions between these components, we use this TLM ports. So basically, UVM TLM ports follow a producer consumer model, and they are supported by non-blocking and blocking communication. So we have two type of blocking and non-blocking communication that we are going to see. So basically, these are the type of TLM ports we have. One is put port and put export, and another is get port followed by get export. Peak port, peak export. This is non-blocking, and we have transport and transport export, and another is port. This is for broadcasting, and another is TLM FIFO. So basically, a TLM FIFO is a mailbox implemented using TLM ports and exports as an EPA to the mailbox. So basically, in SV we were using the mailbox directly, but here we are not using the mailbox. We are replacing mailbox with TLM FIFO. But this TLM ports are acting as an API to the mailboxes, and the TLM API gives you a separation of concerns, which in turn promotes the reusability and maintainability. So let's say if we have two components, okay, so let me draw them. So let's say we have two components, component A and component B. Okay, so these are our two components. Now let's say we have two components, component A and component B. Okay, I need to transfer the data between component A to component B, or the component B is transferring some data to component A. Okay, so in SystemVerilog we were using mailbox concept. So in SystemVerilog we were using the concept of mailbox for transferring the data between these two components. For transferring any transaction packet from A to B or B to A, we were using the concept of mailbox. Okay. Now, if I want to use this mailbox concept in SV between these two components, then what is the procedure I need to follow? I should first declare the mailbox handle in component A, and I should also declare the mailbox handle in component B. This is necessary. Okay, so I should declare the instance. I should declare the handle of my mailbox in my component A, and I will also declare the handle of my mailbox in my component B. Okay, now the instance of the mailbox is not created in A and B. If you remember, and if you have worked in SV, so the instance of the mailbox is not created in both the components A and B. The instance of the components A and B is created in a top model, generally in environment. This particular instance of mailbox is created using mbx is equal to new. So this instance is passed to component A and component B. So let me repeat what I am doing. So in the case of SV, I was using mailbox. I am just creating the handles of my mailbox in my component A and in component B. Okay, I am not creating any instance. The instance of this mailbox is created in a top module, where this created instance is passed to module A and module B. How we are passing these instances? We are passing it with the help of a operator constructor, which is new. Okay, using this constructor, we are passing these instances to the A and B. So this was a dependency. Both, if I want to use a mailbox between my A and B for the communication of the or the transfer of my packet, I need to create the instant. I need to create the handles of my mailbox in A as well as B. This should always contains the mailbox handle. If it is not containing the mailbox handle, you cannot send or receive the data. Okay, and there is a and the instance is created in the top model. Okay, so this is the procedure I am following in the case of my SV. Okay, now coming to TLM ports. Coming to TLM ports, let me show what we are doing basically. Whereas coming to TLM ports, I don't need to create any instances. Everything is built in. So the TLM ports are already built in our components, UVM components. So we are extending our user-defined classes from the built-in classes like UVM component. Okay, if you are developing a driver, you are extending the driver from UVM driver, which is extended from the UVM component. UVM driver is a class, built-in class, which is extended from UVM component. And let's say if we are developing a sequencer, our user-defined sequencer, that will be inherited from a class which is known as UVM sequencer, and that particular UVM sequencer is further derived from your UVM component. So the TLM ports concept is already, this particular TLM ports mechanism is already present in your UVM components. Okay, so that is what which I have said. So let's say you have two components A and B. Okay. Component A has a thread doing puts and component B has a thread doing gets. Okay. So they are both connected through a common mailbox, which means they both must declare handles to a matching mailbox. This is the case which I was talking about in SystemVerilog. Okay, and this creates an unwanted dependency. At some point, I might want some other components other than a mailbox to connect to. Okay, so like some kind of arbiter. So I would need to modify the handle types in the components. But in the case of TLM, this gets, so basically TLM gets rid of that particular dependency. Component A can have a put port and just requires that what it is connected to implements a put method, and component B can have a get port and just requires that what is connected to implement the get method. That's it. Okay, so you don't need to pass any instance, and you don't need to create anything. There is no dependency upon. Now, so in TLM ports, we have some terminologies that we should know. So the first thing is a port. So a port is the initiator or the sender of a transaction or a method call. Okay. So it is used by the component that wants to call a TLM method like put, get, and write. So put, get, and write, these are methods. And these are declared in active components like drivers and generators. And the syntax for declaring your port is UVM blocking put underscore port, and you should mention which type of data you want to communicate or you want to send across the TLM ports. That particular type you should mention here, followed by the variable name, followed by the port name. And let's say if we have two components, one is generator and let's say another is driver. So we have two components, one is generator and another is driver. Now, so we have basically three type of terminologies which we are going to use here. One is port, and the symbol for representing this port is square box, and we have one more thing which is known as export, so that is represented by circle, and another is your implementation port, which is also being represented with this circle. Okay, so this is port and this is export and this is implementation port. So these are the symbols which I'm going to use for this type of things. So one is port, which is represented by square bracket, and another is export, which is represented by circle, and another is implementation port. So what we are doing basically in this TLM ports. Now, in the case of SV, I will come back to once again to SV. So in the case of SV, if I want to use the mailbox handle, and let's say if the generator is driving some data or data packet to the driver. Okay, so what it will do, so generator, what is the code which we were having, mailbox handle dot put off the transaction data, and the driver, what it was doing, it was just receiving that mbx dot get off data. Okay, this was we were doing in SV, and this particular instance is not created in driver or generator, it was created in the environment. Okay, mbx is equal to new, and this particular instance we have created in the environment, we are passing it to the driver, uh, generator, and the driver. Okay, that particular instance we are putting and getting the data. This was happening in the case of SV. Okay, now in the case of UVM, what we are going to do is, let's say we have again generator and a driver. So let's say generator is our initiator and driver is our target. So let's say initiator is our generator and driver is our target. So initiator will always have a port and target will have a implementation port. Okay, so target will have an implementation port. This is an implementation port, and how to differ with export and implementation port, in few seconds I'm going to tell you. Okay, because these two are having same symbols, right? So I will tell you how to differentiate with them, and this is nothing but your port. Basically initiator will initiate the transaction and target will implement that particular thing. Okay, now so generator is having a port and target driver is having an export, sorry, driver is having a port. Now, so generally this particular initiator is just going to call the method, and the method body will be implemented in the target. I will write down here. So basically initiator, the role of the initiator is nothing but it is going to call the method. The method is nothing but it is a function or it is a task. And the target, it is going to have the body, or you can say the logic for the method. So this is what we are going to do. So basically the initiator, it is going to call the method. How it is going to call? Using the TLM port. So it is going to call that particular method. Okay. And the target, it is going to have the body or logic for that particular method. Okay. So this is what the initiator and target are going to do, and they are going to communicate with each other. Okay. So before going to see one example, first let us see the definition of your implementation port also. So the implementation port is the actual implementation of the TLM interface methods, and it is a target or responder of a call. So it is where the actual functionality like put, get, or write is implemented. So using passive components like monitor, scoreboard, subscribers. And the syntax for your implementation port is UVM blocking put underscore IMP, the type which you want, and followed by the class name which you are using this particular implementation port, followed by the port handle. Okay, so this is the syntax for declaring your implementation port. Now let us try to see this with an example so that things will be more clear. Yes, so first let me declare the libraries. Tick include UVM underscore macros dot svh, and one more is import UVM underscore package. Now, so let me create a transaction class which I'm going to communicate with in my two modules, class transaction, which is extending from UVM underscore object, and let me register it UVM object utils transaction. So this is a class which I'm creating, and let me create a new function also. And since it is an object, we don't need any hierarchy, and super dot new of name followed by end function. And here I'm going to declare one data item which is, let's say, rand data, rand int data. Now and let me create a function. So function void display, and let's say it is having string message. So let me display some message $display percentage s, the value of data is percentage d, comma message, comma data. So we are displaying this and followed by end function and end class. So I'm creating just a simple transaction class which is extending from UVM object, and I'm registering that class. And in this class, I have a property which is known as data, and I've written my new function and display function. Now, so let me create a one simple component. Let's say class generator. Let's say UVM generator, which is extending from UVM component. Let me register it. Take UVM underscore component underscore utils UVM underscore generator. So let me create a new function also. Function new string name is equal to UVM underscore generator followed by UVM underscore component parent. So these are the two arguments, and super dot new of name comma parent end function. Now So in this UVM generator, let me create a UVM TLM port also. So this is an initiator. In this particular case, what we are seeing, this particular diagram I am following. So where is the diagram? This diagram I'm following, where my generator is an initiator and driver is an target. So I'm following this. So my generator is going to have a UVM TLM port. So how to declare UVM TLM port? UVM underscore blocking. So this port and implementation port, these are blocking ports. So what do you mean by blocking? That also I'm going to explain. Underscore implementation, what is the type it is expecting? It will only accept a transaction class type. Okay, transaction, and let's say the port name is put underscore port. So basically we are sending the data. So before going to see the further code, let me explain some type of ports. Yes. So basically in TLM ports, in UVM TLM ports, we have two kind of ports. One is push based and another is pull based. So in push based, we are going to use put as well as write. Okay, this write we are going to discuss further in our sessions, but we are only concentrated upon this put. And we have pull based ports. One is get port and another is speak port. This speak also we are going to discuss for in our further sessions. Now we are only going to focus upon this put port and get port. Okay, so let me explain what do you mean by put port and get port by this example. So I'm using a put port. So this is our initiator and which is going to have your put port. Now so within a function new, after sending this, I need to create the instance of this put port. So put underscore port is equal to new of put underscore port comma this. Okay, yes, followed by n function. Now so in our run underscore face task, what we are going to do is run underscore face UVM underscore face of face. So what I'm going to do is here I'm going to first create my instance of my transaction class handle. So transaction txn, and now let me create my instance for my transaction class handle, transaction type id create of my transaction. So I've created my instance of transaction. Next, so let me call let me call the randomize method using the transaction class handle dot randomize. Now, after calling the randomize method, so all the property, that is the data, has been randomized. Now, what I'm going to do is using this put port, I'm going to call the put method. So put underscore port dot put of tx. So I'm passing this and followed by end task. So if you carefully observe, we are calling the method which is known as put. Okay. So if you carefully observe, we were calling the method put in the generator. We are just calling the method put, but this put method, we are calling it with the port handle, port dot put. Now, but where is the logic for this put is written? The logic for the put is written in the driver. The logic for the put is written in the driver. We are calling this particular method, but where is the method declared? The method, it is declared in the driver. So this particular driver method put, we are calling it using the port. So port dot put, and we are calling this method. So that method is being called, and we are passing the transaction class handle to the driver. So that is what. Why I am calling this generator as an initiator? Because generator, which is an initiator, it is only calling the put method. It is only calling the put method, and the method is implemented in the target. That is why it is using, the driver is using an implementation port. Okay, so that is why the name implementation port is named. Okay, now so that's it. We have written the UVM generator. Now let's say we have another class which is known as driver. So UVM driver, which is extending from UVM underscore component. Let's say, so class driver, which is extending from UVM driver. So let me register this, and let me write down. Now, in this driver, we are going to have an implementation port. We are going to have an implementation port. Why the name implementation? Just now I have told you. So UVM blocking underscore implementation imp hash. What is it is expecting? The class type, it is transaction, and in which class we have written it is in the driver class. So I've written it and followed by the port name, that is, let's say, put underscore imp, put implementation port. And let me copy this new function. Now here let me write down the task which is known as put task. So which is expecting a class transaction type, let's say txn. So it is expecting this order. So this method we are calling here in the case of in the generator we are calling. And if you see this put method, it is also a built-in method. We are basically overriding this put method which is already present in the base classes, basically, that we are overriding in our user defined classes. So what we are doing, we can write down our own logic. So what we can write is, so after receiving this transaction class handle, I can call one task which is known as drive task, and I can pass this transaction handle to the uh, drive task. Okay, I can write down a task which is known as drive task, and this particular drive task is basically driving your data. So like this, I can write down whatever the task which I have. Okay, so I can write my driver logic, and I can pass this transaction object. So using this driver logic. So this is how I can get the data and followed by end class. So this is how I can use my TLM ports for basically communicating between my generator and driver. In this particular case, now afterwards, what I should do is I should create an agent which is extending from UVM agent, and let me register this, tick UVM component agent and new function. Now, so we have a build phase. So function void, we have seen this build phases, run phases, everything in our previous session. So if you have missed those recordings, please watch them. Super dot new of, sorry, super dot build underscore phase, phase we are passing, and I'm going to create my driver and generator instances. So let's say this is my UVM generator instance. Let me create it in my agent. First of all, let me declare these instances, and one is driver instance. Yes. So let me create the instances of them, and one is driver instance. Let me create this. Yes. So this is our build phase and end function. Now within one more phase which is known as connect phase. Now in this connect phase, I'm going to connect my drive I'm going to connect my generators port with my driver implementation port. So how to connect them? So simple, generator handle is genh dot put underscore port dot connect of my driver handle drh dot put underscore implementation underscore port. That's it. So I'm basically connecting these two ports and followed by end function and end class. So this is how I'm connecting my generators put port and drivers implementation port and followed by end class and within environment which is extend, or let me create a test class, which is extending from my UVM underscore test. And let me register it first. And let me create the instance of my agent. And let me create a top module. And in this top module, so before that, in the driver logic, let me display my transaction dot display. I'm displaying this. Okay. Yes. So in the top module, I will call my test class. So within an initial beginning block, run underscore test of test. This is UVM underscore blocking underscore put underscore IMP, because it is a put implementation put, and this is a string. Here it is not get underscore implementation. Here it is put. So a typo here, and this is put underscore implementation. And here we should write the name which we are calling from. So it is driver, and the name of the port is put underscore IMP. Yes, so we can see here the driver, the value of data is being displayed from the driver. So this is how we are going to use our put port. So basically, what we have seen is your put port, where the data is being transferred from the initiator to the target, and the port is having with the the generator. And yes, so we are what we have seen just is your generator. The data is being transferred from the generator to the driver, and the generator is the initiator, and the driver is a target. And the data flow is from left to right, and the port is having with your generator, and the logic is being implemented by the driver with the implementation port. Now let's say if I am having this kind of scenario where I'm having the generator and the driver like this, and where your driver is your initiator and the generator is your target. Okay, so let's say the driver is the initiator and the generator is a target. Now here the generator is a target and driver is the initiator, but we need to have the data from the generator itself. We need to get the data from the generator itself. So we are getting the data from the generator. So in this particular case, we are using get port, and here we are using get underscore implementation port. So here basically we are pulling the data from the generator, and here we are pushing the data from the generator. So these are the two differences of your put port and get port. So the get port method we will see in our next session. So that's all about this video. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you.